Welcome back, everyone. And here we will continue our discussion about finding derivatives using the shortcut rules, and we continue with the product rule. Now, the product rule you're going to see as in this box is not very simple looking. It seems pretty cumbersome and complicated. So the first thing I'd like to do is to explain to you why the product rule has to be that way. Why not simpler? Like when we had a plus or minus in the middle, we could distribute the derivative operator over each one. But when it's a product, you couldn't just say the derivative of f of x times g of x is f prime times g prime. It just doesn't work. Instead, there is this complicated looking formula here. But let me first explain why we have to have that. Okay. So let's look at, for example, this example number 4. Okay. So if we didn't do any better, so I'm going to put a big question mark here. Is this equal to? Okay, because it's not going to be equal to, but just, is it, okay, so if you take derivative of the first one, derivative of 2x is 2. And if you take the derivative of the second one, which is 3x squared, and you multiply them, you will get 6x squared. But again, I'm going to put a big question mark all around this. Is this true, okay? For this particular one, the product is easy enough that we can simplify it. So I'm going to do the second way to check that answer. So it's going to be, if you simplify this, 2x to the 4, and now take the derivative, it'll be 8x cubed. And it's not the same as that, right? So if it was the same, and if that rule was the correct rule, you would have to get the same answer, but it's not. So we can see the simple, when you have a product distributing the derivative operator over the product, it just doesn't work that way. So we do need indeed a more sophisticated rule to handle the products, derivatives of products, and that rule is called the product rule. And the way it works, let's go back to the formula. Sorry, I guess my page, here it is. Okay, so the way it works is you take so if this is a product of two quantities, both of them have the variables. You take the first one times the derivative of the second plus the second one times the derivative of the first. One way to write this is f times g prime plus g times f prime. But note that I could have also written like this, g times f prime plus f times g prime. This is exactly the same because there's a plus in the middle and addition is commutative. The whole point is you use one, multiply by the derivative of the other, plus you reverse the order of things. So let's apply it now to this one that we just did over here. So if this is my f and this is my g, and I want to so take the first one as it is, using the product rule of derivatives, times, so the first one I copied, times the derivative of the second one, which is 3x squared, plus the second quantity as it is, times the derivative of the first, which is 2. Now, there's a plus in the middle, so first I can simplify this product as 6x to the third, and simplify this product is 2x to the third, and we're getting 8x to the third as the derivative of this. And if you remember with our method where we simplified it first and then took the derivative, this matches that. So this is indeed the correct answer. So as cumbersome as it may seem, this is the right way to take the derivative of a product, and we're going to use it from now on. Just remember, you can use your own order of the way you want to do it. I always go, for some reason, by habit. I write the first one times the derivative of the second, but it doesn't matter which order you go in. Okay, so here we have another product, and for the practice of, in order to practice the product rule, I'm going to not distribute this, although you could do it that way also to check your answer later, okay? And in the future, there'll be examples where we won't be able to distribute things, so it's important to know the product rule. So let's begin. Write the first one as it is. 3x squared plus 1 times the derivative of the second one, which is just 5, right? Derivative of 8 is 0, plus, product rule has a plus in the middle. Write the second one as it is, 5x minus 8, and multiply that with the derivative of the first one, which is derivative of 3x squared plus 1, and that's 6x. At this point, usually you're going to have some things to distribute and simplify. So for instance, I could go 5 times 3x squared. That's 15x squared, and 5 times 1, so plus 5, and then let's distribute these. 6x times 5x, that's 30x squared, minus 48x. And if we simplify this, I can combine like terms, 15x squared plus 30x squared, That will give me 45x squared. And then the next highest degree term is minus 48x plus 5. And I think it would be a good example practice if you distribute it first and then take the derivative. You should get the same exact answer, which is nice. You have a way to check these questions answers by doing both ways if you choose to. So let's do another one, another product rule example. G of x equals x squared plus 1 times x cubed minus 5. We're going to find g prime of x, again, using the product rule, not using the distributing it first method. So with the product rule of derivatives, let's write the first one as it is, times the derivative of the second one, which is 3x squared, plus write the second one as it is, times the derivative of the first one, which will be 2x. So once again, let's distribute. This is our first term, this is our second term. Each one has a product, so we're going to simplify those products. 3x squared times x squared, that'll be 3x to the 4, plus 3x squared times 1, which is plus 3x squared. And then 2x times x cubed, so there's a plus 2x to the 4, and 2x times negative 5, so minus 10x. Again, let's simplify them with the highest degree terms. So combine the x to the 4s together, we get 5x to the 4th. And then the x squared is only one of them, which is plus 3x squared. And only one x term, so minus 10x. So that's how we're going to leave our answer. And this next one is interesting because it's kind of a problem where like you don't even know what f of x is, but we can still take the derivative because they give us some additional information. So we're looking at number 7. G of x equals x squared times f of x. F of 4 equals 5. F prime of 4 equals to 2. What is g prime of 4? Now remember, since this is what we're trying to get, and since g of x is equal to x squared times f of x, let's first find g prime of x. So we're going to find g prime of x. Now, notice there's a product here, x squared times another function of x, so we have to use the product rule. So applying that, you write the first one as it is times the derivative of the second one, plus write the second one as it is times the derivative of the first one. Okay, normally we're done because we couldn't simplify since we don't know what f of x is. However, they asked not for g prime of x, but g prime of 4. So let's go ahead and plug in a 4 everywhere we see an x. So 4 squared is 16 times f prime of 4. I will simplify that in the next step, plus f of 4, and then times 2 times x, or 2 times 4, which is 8. So now let's go ahead and plug in what we know about f prime of 4. So 16 times f prime of 4, which is 2. So 16 times 2 plus. And what do we know about f of 4? That was also given at the top, right? 5 times 8. So here we have 32 plus 40. So our final answer will be 72. Okay. So that's pretty much all there is about the product rule. Now let's take a look at the quotient rule. Okay, once again, quotient rule also has a weird looking formula, as you can see up there. And again, I'd like to explain to you why the intuitive formula doesn't work, and then we're going to go down to some examples. So the intuitive one might have thought that, you know, maybe I can distribute the derivative operator to the top and the bottom. So why couldn't I just do f prime over g prime? I'm going to put big question marks next to this. Can I do this? Okay. I can even tell you right now the answer is no, so you don't learn anything incorrectly. But I want to show you through this example why that doesn't work. So if you take the derivative of the top, you get a 5. If you take the derivative of the bottom, you get a 2x. So the question is this possibly the correct answer? Okay, so now let's do this with this particular example. We have the luxury of being able to simplify. 5x over x squared, you know, the x from the top and one of the x from the bottom can be simplified. That's the same as 5 over x. That's the same as 5 times x to the negative 1. Now let's take the derivative of the simplified version. 5 times x to the negative 1, because we already know how to take derivatives of x to a power, right? So when we do that, you bring the power down, so get negative 5, subtract 1 from the power of x, it'll be x to the negative 2. We'll get negative 5 over x squared. Okay, so this we know is the correct answer because we have reduced it to a single term. We know how to take derivative of a single term. The answer should have been negative 5 over x squared. This method does not work. Taking derivative of the top and derivative of the bottom, it doesn't work. So we need a more sophisticated formula. Once again, they are providing that to us here. But later I'm going to show you at least just a quick understanding of where do these more sophisticated formulas come from. How did they come up with that? At the moment, let's just practice to use it. So here's what the formula is saying to us. Okay, when you're taking derivative of f over g, notice you have g times f prime minus f times g prime all over g of x squared at the bottom. So the easiest thing to remember is whatever the bottom was, you're going to end up with the square of that same quantity at the bottom. For the top, notice first of all there's a minus sign in the middle as opposed to a plus sign with the product rule, right? But other than that, it's similar to the product rule, the top part, right? But it has to be in a specific order because there is a minus sign in the middle. It's not commutative like the product rule was. And the easiest way I found to memorize this is if you have like, think of this, let's say the term that's on the higher part of your fraction over the lower part of your fraction, okay? And one way to look at this top part is to say let me start. So you could take the lower term times the derivative of the higher term, so low d high, okay, minus the higher term times the derivative of the lower term, all over the lower term squared. And there's even like a little rhyme that goes with it to help you memorize. So low d high less high d low, draw a line down below, denominator square root go, something like that. So again, you may have your own way of remembering this, but this has helped me when I was learning the quotient rule. So we're going to look at the original quantity. We're going to start by taking the lower one. So the derivative of this is take the lower one exactly as you see it, times the derivative of the higher term, which is 5, minus, again, not a plus, but a minus for the quotient rule. Now you reverse it. So now I take the higher one, which is 5x, divided by the derivative of the lower one. So here we have low d high less high d low, all over denominator squared, which will be x squared to the second, and that's x to the 4. If we simplify the top, what we have is 5x squared minus 10x squared divided by x to the 4. And if you simplify it further, you get negative 5x squared over x to the 4. And if you simplify that further, notice x squared on the top can be simplified with x to the 4 on the bottom. So it'll be like negative 5 divided by x squared. And if you had kept our original trial and error process, that was indeed the answer we expected to get. So again, this method works. This is what we're going to use when we are using the quotient rule. And let's apply it to the second example. So again, I'm going to call the higher term, this is the lower term. So applying the quotient rule, first of all, I know right away the bottom will be squared. Okay, for the top, I want low d high. So the lower times the derivative of the higher, which is 1. So 3x minus 1 times 1 minus high d low. The higher one times the derivative of the lower, which is 3. Everything over denominator squared. And we just have to simplify the numerator. Be very careful when you distribute that negative sign. Usually there's 2 terms to deal with there. So don't forget. So 1 times 3x minus 1 is itself. If there was another number there, for sure, I would have to distribute that first, right? And then minus 3 times x. And then minus 3 times 2. So important to remember that negative distributes to both terms, okay? And then don't forget the bottom is still there, 3x minus 1 squared. And in the numerator, we lose the 3x and plus and minus, they cancel. Negative 1 minus 6, that's going to be negative 7 over quantity 3x minus 1 squared. And notice for this one, we didn't have the other option of simplifying it first, like we had with the first question. We could check our answer. So for the quotient rule questions, you just have to apply the quotient rule. For the product rule questions, you have two approaches sometimes, but I would still ask you to practice with the product rule so you get really good at that. But because next section you may get something like this, x times sine x. Notice you couldn't even multiply those, right? You would have to use the product rule if you were asked to find the derivative of that quantity. So both of them are important to know.